Kia ora, here's question 2C from last year's scholarship calculus exam. This is near the end of a question, so you know it's going to be trickier than the ones at the start. It's all about logs and a tiny little bit of trig. Alright, we're given an expression here, the log to this base of cos theta, and we're told that that equals k. We're asked to use that fact to write this log with a different base in terms of k. So first thing to notice is that we've got logs with two different bases, so it's probably going to come in useful to write the logs with the same base. So if we do that, this is how we do it. So the log to base a of b is equal to the log of b divided by the log of a. I'm leaving out the base in there. It doesn't matter what the base is. You might want to think of it as base 10. All it's saying is that it's got to be the same base for the numerator and the denominator. So what we're going to do is we're going to rewrite both expressions using the change of base rules. But we want to do a little bit of preliminary work first. So the first thing I'm going to do is just note the following, which is that tan theta plus cot theta, which is the log of that, the base of the first log, can be written like this: sine theta over cos theta plus cos theta over sine theta. So adding the two fractions, here's what we get. We get sine squared theta plus cos squared theta, and that equals 1 over sine theta cos theta. Okay, so just make sure that you're writing this down as you go if you are following through. Hopefully what you'll do is you'll pause and you'll have a go at the next steps in the problem and just see how far you can get. So we're going to use that fact later on. But first we're going to just directly apply this to the top expression there. Okay, so k is equal to the log of that. Right, so doing the change of base, we get the log of cos theta over the log of tan theta plus cot theta. But because we've done that work above, we know that we can rewrite the denominator like this. Now we're going to use our log rules from year 11 or 12 to simplify the denominator as follows. So it's going to be the log of 1, I'll write it all out, log of 1 minus the log of cos theta plus the log of sine theta. I'm not going to go over those. I'm assuming if you're watching this video that you've got a very good handle on those rules. Okay, so now we're going to simplify that next. So that equals negative log of cos theta over the log of cos theta plus the log of sine theta. So that's k. Now it turns out that that's not quite far enough for getting right to the answer, but if I were doing this in the exam, I wouldn't have seen the next step to do straight away. So I'm trying to do it how I think you'd do it if you were attacking the problem without having the answer schedule to look at. So what we're going to do now is we're going to move to the next log expression and look at what the point is there. So remember, what we're trying to write is the log to base tan theta of sine theta, and we somehow want to get that as an expression that's just got k in it. Okay, so doing my change of base thing here, I get the log of sine theta, it should feel a bit easier this time, over the log of tan theta. We know that tan theta is sine over cos, so I'll go straight to that. So that gives me an expression that looks kind of like k, but not, sadly, not quite. So now what I'm going to do is I look back up to the top of the page and I say, well, I must be able to do some more with that expression for k. And it turns out that if you stare at it for long enough, we can just about get rid of the log of the cos theta in here and here. And we're going to do that by dividing the top and bottom of the fraction by the log of cos theta. So that's going to be my next step. So just in terms of strategy, I'm going back to this and I'm going to now manipulate this, and then hopefully I'll be able to plug things in down here and get to the answer. Alright, so k was equal to this. So dividing everything by the log of cos theta, we're going to get this. Okay, so the top line has been divided and the bottom line's been divided. Right, cross multiplying now, I get k times 1 plus log of sine theta, log of cos theta, equals -1. So where we're going is we're going to get an expression for the log of the sine over the log of the cos in terms of k. Just takes a couple more pages of algebra, sorry. Dividing through, so now dividing through by k, and the reason we're doing this is because we can see the log of cos over the log of sine coming in that other expression. So this equals -1 over k minus 1. And we could write that now as -1 minus k over k. Alright, so now let's hop back to where we ended up with the sine expression. We'd started from the log of tan theta to base tan theta of sine theta, and we'd got down to here. And we did that, if you'd seen the change of base thing, you would have got this step. Okay, this bit is not hard, and you should be on the lookout for change of base places in the paper. Now, we're going to do the same thing that we did before, only this time we're going to divide the top and bottom by the log of sine theta. So in the numerator we're going to get 1, and in the denominator we're going to get 1 minus the log of cos theta minus the log of sine theta. Okay, so we're awfully close to the end because we know that the log of sine theta over the log of cos theta was equal to -1 minus k over k. So the log of cos theta over the log of sine theta is equal to, let's be careful here, -k over 1 plus k. Alright, now I could have gone back to this expression and written it like that. Okay, so what I'm doing here is I'm just taking the reciprocal of both sides. All I've got to do now is 2 more lines of working. Very happy at this point if I'm sitting there, because I'm going to substitute that into there, and then clean it all up. So this equals 1 over 1 minus negative k over 1 plus k, which equals 1 over 1 plus k over 1 plus k. So my final answer is k plus 1 over 2k plus 1. Thank you for watching. Please let me know if the sound quality was okay on this. Been having a bit of trouble with the iPad, and apologies for the really messy structure. So if you look at the answer schedule to this question, you'll see that they do it in about 4 lines. But I think the hard part in this one is seeing that it's okay to go part way down as far as you can get and then to start working down the other side. We don't usually like it in maths, it's not that elegant, but if you're desperate, sometimes it's the best way to proceed. And the same thing goes for when you're doing hard trig proofs.